Hey there, this video is to help us reviewing our exponent properties. So I have all of the properties that we've reviewed up in this section here. We're going to look at a few examples on the side that have already been done, and then we'll work through a few more examples together. So our first property we learned is the product property. We can see that here. When we are multiplying two expressions with the same base, we add together the exponents. So if this exponent is 20 and this exponent is 9, we add those exponents together and our final answer is x to the power of 29. So in this example, we have x to the power of 8 times x to the power of 3. So if we add those together, we get x to the power of 11. In this example, we're multiplying not just these bases, but also there's a coefficient, this -4, in front of this term. So we're going to include that in our answer. -4 times, well, if there's no coefficient in front of this term, figuring out how to use my touch screen here. If there is no coefficient in front of this term, we treat it like it's a 1. So we multiply -4 times 1 is -4. And if we add together the exponents, x by itself is x to the power of 1 times x to the power of 8 gives us x to the power of 9. There is a distributive rule for products that says if we have an exponent outside of a group of terms in parentheses, we distribute that exponent to both the coefficient and the variable inside those parentheses. So we have -3x all squared, which means we have to do -3 squared, which gives us 9, and x squared, which is just x squared. So in this example on the side, we have 2x in parentheses to the power of 3. Well, 2 to the power of 3 and x to the power of 3 gives us 8x to the power of 3. Remember that 2 to the power of 3 is not 2 times 3, but it's 2 times itself 3 times, which is 8. In this next example, the negative that is in front of the x, that represents the coefficient -1. So we have -1 to the power of 5 and x to the power of 5. -1 times itself will either be +1 or -1, depending on how many times we multiply. If we're multiplying with an odd exponent, our final answer is still negative, so this is -1x to the power of 5. When we are dividing with exponents, taking a quotient, we do the opposite of what we did when we multiplied. So when we multiply, we add the exponents, and when we divide, we subtract the exponents. We can see in this example here, we've got a to the power of 9 divided by a to the power of 5, and in those exponents, 9 minus 5 gives us a to the power of 4. In this example, number 1, when we subtract those exponents, we know that 10 minus 2 is 8. But since the bigger exponent is on the bottom, we need that term to stay in the denominator of our fraction. So we have a to the power of 8 on the denominator and just a 1 in the numerator. If we are dealing with a fraction that has variables and coefficients, when we're dividing with coefficients, that's just a regular division problem. So -6 divided by -2 is 3, and a divided by a to the third, well, if we subtract the exponents, 3 minus the 1 that we have here gives us a squared, and since the bigger exponent is on the bottom, that a squared is on the bottom. On this next page, I want to review the rest of our exponent properties. So we have the power rule. The power rule is when we are raising an exponent to another exponent. So this will look like we have an exponent inside parentheses, and then right outside the parentheses, another exponent that it's being raised to. And in that case, we multiply the exponents together. X to the power of 9 to the power of 3 again becomes x to the power of 9 times 3, and 9 times 3 is 27. So on the side here, we've got x to the power of 3 to the power of 5. 3 times 5 is 15. This property still works regardless of if we're dealing with positive or negative exponents. So in this example, we have x to the power of negative 2 to the power of negative 3, and negative 2 times negative 3 is positive 6. Just like there's a distributive rule for products, there's a distributive rule for quotients. So if we look at this example on the left, the exponent 3 that is outside of the parentheses needs to be distributed to the numerator and denominator. In the numerator, we have negative 2 to the power of 3 is negative 8, and on the denominator, 3 to the power of 3 is 27. So now in this next example 1, we have negative 1 over 2 all to the power of 5. In the numerator, negative 1 to the power of 5 is negative 1, and in the denominator, 2 to the power of 5, that's 2 times itself 5 times, and we get 32. When we're distributing an exponent to a variable, like in this example, that variable will just take on whatever exponent is outside the parentheses. So in the numerator, we have x squared, and in the denominator, 7 squared. 7 times 7 is 49. The negative exponent rule says that we need to take the reciprocal. In other words, we need to flip which side of a fraction something is on. So we have this example on the side where these terms in the parentheses are being raised to the exponent negative 2. So the first thing I'll do is change that negative 2 to a positive 2, but when we do that, we need to flip the numerator and denominator of that fraction. After that, we're just using the distributive rule from before to distribute that exponent to the top and bottom of our fraction. So in this example on the side, we have negative 1 over x to the power of negative 3. So if we change that to a positive exponent, this becomes x over negative 1 to the power of positive 3. And when we distribute that exponent to the numerator and denominator, we get x to the power of 3, and negative 1 to the power of 3 is negative 1. Anything divided by negative 1 is just itself except negative. So another way we could write this is negative x to the power of 3. And our final exponent property is the zero exponent property. Anything to the power of 0 is not 0, but actually 1. Think of an exponent that's 0 like it's saying we're canceling something out. Well, when you cancel something out, that means you divided something by itself, and your answer is 1. So if we have x to the power of 0, that turns into 1. And notice we still have a negative 2 in our final answer because this exponent, 0, was only on top of the x, not on top of the negative 2. So a similar example is here, 4x to the power of 0, where we have no parentheses. So we still have a 4 in our answer, but x to the power of 0 cancels out and just turns into 1. That's different from if the 0 exponent is outside of these parentheses. Now this means that the 0 exponent is canceling out the 4 and the x. Both of those terms turn into 1, and 1 times 1 is just equal to 1.